Today we're talking about sprites. Now it used to be with sprites, it'd be specialized hardware, but today all a sprite is a character that moves, typically for a game. Truth is, all animation's a trick. If you're seeing something move on a TV screen or a computer screen, the reality is it's not actually moving. I know you think it is, but if you pick up a pen, that pen is actually moving. To get from one place to another, it has to move. Whereas the truth is, anything moving on a screen is simply a series of images shown in succession so your brain thinks it's moving. So this octopus here, it's just a bunch of individual pictures where there's slight changes to the picture. And what happens is your brain knows that to get from one frame to the next, well, it had to move. It's your brain that's slicing it together. And we can make this easily ourselves. All we would do okay, I have these frames of the octopus. I have in a folder I call octo frames, and they're just numbered 0 to 21. Just going to load them all in as images into a list here. Then all I'm going to do is display them one at a time. And if you look, the exact same animation. I think it is, unless one of my things got messed up. So typically in a game, you're not just going to want to load an automatically animating sequence. You want to have full control over how it's animating, because you want to control whether, it moves, it walks to the right or walks to the left or throws a punch. All these things you want to have full control of. You don't want to rely on just some animated GIF. And even getting an animated GIF isn't the easiest. Okay, so two things here. I have a list, all the pictures. I have a variable called frame, tells me which frame I'm in. All I'm doing is increasing it by 1 each time. When it hits 22, that's out of range. I go back to 0 so that next time I'm showing the first frame again. Okay, so typically when we want to do a sprite, you just Google up whatever you want and throw sprite sheet after it. And you'll find sprite sheets for loads and loads of famous characters. There's other sites that are devoted to giving sprite sheets. There's loads of them out there. They're not that hard to find. Now, how do you actually use these sheets? Well, depends what the sheet's like. If it's a monospaced sheet, like this. Now, monospace means each sprite takes up the exact same space on the sheet. Well, you could mathematically determine which one you want to go to. Now, this is a little robot that spins around and moves around, but each of these takes up the exact same space. And again, you could do the math in the X and Y and grab a subsurface and display that. Unfortunately, most sheets are not monospaced. As a result, you're going to get something that looks like this. You can't mathematically determine where to get the frames from. So I find it's best if you extract them. Now, I've written a couple programs that help you extract these to make individual images. The simplest is called split.py. Now, for these programs, you don't need to understand it fully to use it. I'm providing it as a utility to make your life easier. It's not something I expect you to go in and change and make part of your program. I don't want you to spend forever cutting these sprite sheets up using some manual tools like Paint. Okay, so to use this, all you do is you give the name of the sprite sheet. Now, it should be a PNG. If you get a JPG, it's not going to split very well. The the background's not going to come out quite right. Now for this split one, I need my PNG to have a transparent background. If you have a sprite sheet like this one and it's not transparent, well, find one of the many utilities to get rid of it. I like using Photoshop Elements, but there are online background eraser tools out there. You just basically click on the color and it goes away. Okay, so when I run this program, what it'll do, my program tries to find all of the pictures. And when it finds them, it breaks them up and it writes them as separate pictures and just numbers them as it goes. So what it's doing to get a feel for this, okay, so it first tries to find rows of pictures and does this by trying to draw lines across. It draws lines of transparent pixels until it finds one that's not transparent. It says, this is the top of that row. Does the same until it finds the last non-transparent at the bottom. And then it goes and it tries to cut vertically. The same concept, keeps going until it finds the first pixel, last pixel, makes that a box. Now, for some things, it's not going to work out. Like this animation down here, if part of him was actually separate, it would split it up. And you'll see with different animations, it's going to mess up. But this will do 90% of your work. It just won't name them very well. They're just going to be numbers. Usually that's okay. Now, my split 2 is a little more advanced. Again, well, there's two ways to use it. You can either put it alone in a folder with a PNG and it'll grab the first one, or you can just put the name in. If you want it to automatically grab because you're just throwing them in the folder, you just comment this out, or you just identify which sheet it is. So I'm going to use this sheet here. So when I run it, it shows the sheet. And what I do is I draw a box around the ones that I think is one move. Okay, this looks like one move. So I box it. And my program is trying to preview what's going on here. Now, if you look here, this bike here shouldn't be going back and forth. Now, if you look on the bottom here, I have little red dots. The little red dots allows you to stabilize the image. And what you do is you find something that should be non-moving on the image. This little part of the car here. I'm going to take the dot and I'm going to move it on there. For all the images. And you'll see my program tries to stabilize it. Now, for an image like this, it doesn't have to be perfect. Quite frankly, it's better if it's moving up and down a little bit because it makes it look like it's, riding on the wind or something like that. But all it's doing is by moving that circle, my program can do the math properly to pad these extra ones out with a little extra space. When you're done, you hit enter, you type in the name of it, enter again, and you will see in the folder, it makes a folder called bike, and it puts in there bike 0, bike 1, bike 2, bike 3, bike 4. So this one does a great job of organizing the images and previewing to stabilize. And it'll work for most of them. Now, for a lot of these images, you'll see it only occurs in one direction, so it's left, right. And that's okay. You're usually not worthwhile to do them twice. You can just transform.flip and get it backwards. Again, I could stabilize this image again, but you get it. Sword, enter, got it. Okay, so those are the two utilities that I've written. You're probably going to find one of them helpful. Okay. So how do you actually use this? Let's give an example. So a more complicated example than simply showing the image, I have this example of a guy walking around. And this little Mario guy, he can go up and he can go right and he can go down, he can go left. The key to understanding this example is understanding how the data is stored. So Mario Pix is all the pictures of all the sprites. So here's how I load the image. It's a two-dimensional list of images. So the first dimension is the move. So 0, 1, 2, 3. So move 0 is all of him moving right. And then I have frames for each of those. Now, if you look in the folder, which I cleverly closed, there's my original sprite sheet, and clearly I used split 1 on this. I just split them all. Now you might say, well, split 1 doesn't organize it very well, and you're not wrong. But what I do here is I make a little function called makeMove, and I tell it the range of the numbers I want to make into a move. So I say image from 1 to 6 is going to be called right. Now, all that means, I say right equals 0, all it means is index 0 is moving to the right. So by loading it first, it becomes index 0. So if I went into this program and I shuffled the order of these, it would mess up. Okay, just the fact that I say images 7 to 12, well, that's moving down. That's just me looking in the folder and saying, oh, those ones, they show them walking down. Same with the up, same with the left. So it's key to understand this two-dimensional list. And when I move Mario, cleverly called move Mario, oh, Mario himself is a list. Yeah, you'll see I like to do this with objects. So I see Mario as an object. He has multiple things about him. It makes it really easy to edit him in my functions because the list itself can change. If I passed in Mario X, Mario Y, I couldn't change those. I'd have to return those, and that's a bit of a pain. So instead, if I have it as a function, it's easy to modify it. And you see I keep track of his X, Y, the current move, that's from my list, and the current frame in that move, same. Okay, in Move Mario, I get the keys that are pressed. Now this K right, that's built into Pygame. This move and this right, those are mine. Those are just the numbers here I named. Now, the more you have variables that are just sitting as like 0 and 1, the harder the code is to understand. So if you're gonna have, these are called magic numbers. If I have the number 0 there and it means something, but it's not obvious what it means, it's called a magic number. So you want to avoid those. So I just name them down here, and I use them here. It makes the code really easy to read. Okay, so I'm saying if the key is right, hey Mario, remember that your move is to the right. Now I need this for when it comes time to draw. And then I move the X variable for Mario. And the same for left, down, up. Now, if I didn't move at all, I don't want that frame to keep advancing. I'm about to advance the frame right here. So to offset that, I just subtract the same amount I'm about to add, and that will cause him not to advance his frames. And then I simply say, if I've gone to the end, so if I go to spot 6, which isn't a spot 6, go back to 0. Now to slow down the animation, rather than adding on 1, I add on 0.25. Now, you can add different numbers on here. Now the reason I'm doing this to slow it down, rather than changing my clock, if I change my clock, this example will work fine. The problem is, Once I go to make an actual game, everything in the world slows down, and that's not good. So instead, if I just want to change the animation, add by something less than 1. The only downside of this is that when it comes time to draw, I'm going to have to turn that back to an integer, but that's not a big deal. Okay. When it comes time to draw the scene, I have these two variables. I have the move and the frame. They're stored at Mario move and Mario frame. And those tell me what move in here, what frame in here. I find the exact image I need right there, and I just split that. Now, I'm storing the center of Mario. This is going to make it a little easier when he turns left, right, so he's not jumping around. And I put an example here. You can uncomment this if you want to. Oh, I guess I'll do it for you. So if I didn't draw from the center and I drew from X, Y, you'll see when I run it, when I turn around, he entirely jumps. It's not a huge effect, but he jumps a little too far. If you play with yourself, you can kind of notice it. Not a huge deal, but I like it to look smoother, so I leave the draw from the center. And that really is the whole example. So if you want to use my make move, you have to understand it. There's not much there to understand, but you're welcome to use it. And this is a pretty good template for using sprites. You're going to have some of your own problems along the way, and you're going to have to modify that. That's okay. But that's it. I hope you enjoyed the video. Hope you're still staying safe. I hope you're working every day. And I will have some more content tomorrow. Again, if you're not using sprites in yours, just do a quick once over of this, play with the examples a little bit, and get back to what you need to be doing. Have a great day. Bye-bye.